Imagine looking up at the sky and watching the sun simply vanish. Not explode, not dim, vanish completely. For this thought experiment, we'll assume the sun disappears instantly, taking all of its mass and energy with it. Earth, the moon, and everything else remain unchanged for that exact moment. No replacement star appears. The laws of physics still apply as much as possible, except for the impossible act of making the sun disappear in the first place. And the first surprise is this: we would not notice immediately. The sun is about 150 million kilometers away. Light takes roughly 8 minutes and 20 seconds to reach Earth, so for those 8 minutes the sky would look perfectly normal. Sunlight already on its way would keep arriving. The Earth would also continue orbiting as if nothing had happened. Then, all at once, daylight would end. The sun would disappear from the sky, and the world would be plunged into darkness. Not the darkness of night with a bright moon and scattered city lights, but a sky filled with stars. The moon would vanish as a visible disk too, because moonlight is just reflected sunlight. The planets would fade. Even the blue sky would disappear, since that color comes from sunlight scattering through the atmosphere. At the same moment, Earth would lose the sun's gravitational pull. Gravity, like light, does not update instantly. The information that the sun is gone travels outward at the speed of light, so Earth would remain in its orbit for those same 8 minutes and 20 seconds. After that, Earth would no longer curve around the sun. It would travel in a straight line, moving at about 30 kilometers per second, or nearly 108,000 kilometers per hour. The planet would not suddenly stop, reverse direction, or fly directly away from the sun's old location. It would simply continue along the direction it was already moving. The moon would keep orbiting Earth because Earth's gravity would still be there. The planets would begin drifting on new paths too, but Earth's immediate problem would not be orbital mechanics. It would be temperature. Sunlight supplies Earth with about 360 watts per square meter at the top of the atmosphere. That energy drives almost every major surface system: winds, storms, the water cycle, and photosynthesis. Remove it, and the planet begins losing heat to space while receiving almost none in return. The first hours might feel surprisingly ordinary. The oceans and atmosphere contain enormous amounts of stored heat, and concrete, soil, and buildings do not freeze instantly. But temperatures would start falling almost everywhere. Within days, the average surface temperature could drop below freezing. Within weeks, much of the land would be locked under ice. Plants would be hit before the cold became extreme. Photosynthesis would stop immediately, because there would be no sunlight to power it. Crops would begin dying, not because they froze right away, but because their energy supply had been cut off. Food production would collapse in a matter of weeks unless humans had artificial lighting and controlled growing systems. The oceans would not freeze solid overnight. Water is a remarkably effective thermal buffer, and the upper layer of the ocean would freeze first, forming an insulating lid. Under that ice, liquid water could remain for a very long time. In some places, geothermal heat from Earth's interior and heat released by radioactive elements would keep subsurface water liquid. That means the planet would not become a perfectly frozen ball. It would become a frozen world with pockets of warmth hidden underneath. The surface, however, would keep cooling. Earth's average temperature today is around 15 degrees Celsius. Without sunlight, it would eventually approach a much lower balance set mainly by geothermal heat. A reasonable long-term estimate puts the surface around a few tens of degrees above absolute zero, roughly minus 230 degrees Celsius, though local conditions would vary. Before reaching that final state, the atmosphere itself would begin changing dramatically. Water vapor would condense and fall as snow or freeze directly onto the ground. Carbon dioxide would eventually freeze too. As the planet cooled further, oxygen and nitrogen, the gases that make up most of our atmosphere, would also condense into liquids and then solids. The atmosphere would no longer remain a deep, breathable blanket around the planet. Much of it would settle onto the surface as frozen material. But this would take time. The atmosphere has thermal mass, and Earth's oceans release heat slowly. The exact timeline depends on location, clouds, ice coverage, and how efficiently heat escapes. The important point is the sequence. Darkness first, crop failure next, widespread freezing after that, and atmospheric collapse only in the deeper cold. For humans, survival would become a question of energy. A normal house would not protect people for long. Even with insulation, it would eventually reach outdoor temperatures. Cities would lose solar power immediately, and many electrical grids would fail as fuel supplies, maintenance, and transportation broke down. Wind and hydropower might continue temporarily, but wind is ultimately powered by uneven heating from the sun, so it would weaken. Rivers would freeze. Most surface infrastructure would become useless. Nuclear reactors and geothermal power would become incredibly valuable. Underground facilities near geothermal regions could provide heat, electricity, and liquid water. Large sealed habitats could grow food under artificial lights, but lighting plants requires enormous energy. A small indoor farm might be possible. Feeding billions of people would not be. Humanity might survive in scattered underground communities, using nuclear fuel, geothermal wells, stored supplies, and carefully recycled water and air. Deep mines, subway systems, and facilities beneath ice could become refuges. But global civilization, as we know it, would almost certainly collapse long before the final atmospheric freeze. The natural world would shrink toward the deep. Most surface ecosystems would disappear. Forests would freeze. Grasslands would become silent plains. Animals that could not migrate, hibernate, or reach artificial shelters would die. But life would not end completely. Deep beneath the ocean floor, around hydrothermal vents, ecosystems already exist without sunlight. Their energy comes from chemical reactions powered by Earth's internal heat. Microbes could continue living there, along with organisms that depend on them. Similar life might survive underground, around geothermal systems, for millions or even billions of years. The sun's disappearance would also change Earth's future orbit around the galaxy. The sun currently carries Earth and the other planets around the Milky Way. Once the sun was gone, Earth would continue moving through space along its existing galactic path, but as a cold, wandering planet. It might pass near another star someday, but the odds of being captured into a useful orbit would be extremely small. And what about the sun itself? Since our premise says it disappears completely, there would be no explosion, no expanding cloud of fire, and no delayed burst of radiation. In reality, removing the sun's mass and energy violates our understanding of conservation laws. That is the fictional switch in this scenario. Everything after that follows from ordinary physics. The frightening part is how quickly the first consequences arrive. We would get 8 minutes of warning, but only because the universe limits how fast information can travel. After that, the sky would go dark, the orbit would end, and every ecosystem on the surface would begin running on stored energy. The sun feels like a permanent feature of reality because human history is only a tiny slice of its lifetime. But it is not just a lamp in the sky. It is Earth's engine, clock, climate system, and primary food source. Remove it and Earth would not die in one dramatic instant. It would go quiet layer by layer. First the daylight, then the plants, then the ocean's surface, then the atmosphere itself. And beneath all that frozen darkness, deep underground, life would still be waiting, powered not by sunlight, but by the heat left over from the planet's own birth.